let's talk about what spatial operations are and then use the dissolve command as an example of a spatial operation. So with spatial operations, one way to think about that is we have an input layer here. This might be something like roads. And then we run some sort of spatial operation on it, and then we come out with a new layer here. So what we've basically done is we put a layer into a tool, and out of that tool has popped a brand new layer that you didn't have before. You can then take that layer, put it into a second spatial operation, a second tool, and get a new layer out, and then put that second new layer that you didn't have a few minutes ago into a third spatial operation or tool and get a final output layer here. So when we do analysis with GIS, this is the way that we often do it. Let's look at an example in the dissolve command. So the dissolve command uses topology to look at surrounding polygons, and then it decides if, based on the attribute that we're interested in this case it's whether or not it is to the west of the Mississippi or to the east of the Mississippi, what the value is in this column of the attribute table. So we can see we have all of these polygons here in the western US labeled with a 1 from the attribute table, from this attribute is west, and we could dissolve that, which would basically mean that if two polygons that have is west equal to 1 as their value, that line in between them would just be taken away. And we can see that after the dissolve command, now we have a brand new layer out. It has the same outline as the old layer, but now it only has one boundary between the east and west polygons. So here we started with 48 polygons, now we're down to 2 polygons here, an eastern polygon and a western polygon, because all of these lines in between have been dissolved away. The value on one side is the same as the value on the other side. And of course, this is all possible because GIS layers are built with topology. So topology means that all the lines in a polygon layer have a from node and a to node, so they have a direction, and because they know which direction they're traveling as you go from the from node to the to node, they know what their right hand polygon is and their left hand polygon is. In this case, it would have A to the right and A to the left. All dissolve does is it checks to see if the left polygon and right polygon are the same. If it is, it deletes that line, such as this line here. And if it's different, such as this line here, which has A polygon as its left polygon and B polygon as its right polygon, it would not be deleted. So the only lines that remain are ones that separate, in this case, these two different attributes, A, B, and attribute values A, B, and C, and all of the other lines that have the same value on either side have been dissolved. So if we ran it on something like this 1,000+ polygons here, we would get a much more limited number, a much lesser number of polygons in the last case. You might also think that we could almost make the same map by just not displaying all of the boundaries here, and that would indeed pretty much make the same map. The only difference would be that we would not see the outline of this gray layer here, but otherwise it would look the same. So a lot of times dissolves are things that we can make a map display on just by changing the color. But if we really want to get rid of all those lines and be able to, for example, represent the outline of this gray area by a black line, then we have to do the dissolve command before we display the data. So because we're going from more than one polygon to one polygon, how do we deal with the attributes here? Well, when we deal with these attributes, the default is that they're summed. So for example, we can see in this example here, we have polygon A, and it has type equal to 1, and so does polygon D. So if we're dissolving on that type, this line is going to disappear, and it's combined into this new polygon X here. But what about the cost? Well, here polygon A has a cost of 1, and here's polygon A. Polygon D has a cost of 2, so the default is that cost is summed because A and D are both contributing to this polygon X. In the same way, B and C, which have costs of 6 and 3, are both contributing to polygon Y, so they get summed to 9. That's the default. However, we can do whatever we want during dissolve as far as how we're going to deal with this. This once again shows the sum here. So these values are the same as we've seen before. But if we wanted to, we could also We could also take a maximum value. Of this time we're taking not the cost, but the virus. So if we look at X, Y, and Z, which were summed, I'm sorry, if we take a look at X here, which was summed from polygon A and D, then we can see that the virus rating here was 0 and the virus rating here was 9. So the maximum in this case would be 9. So we can take sum, we can take average, or we can take maximum. We can do all of these different things, but we have to deal with the fact that we have less features in the dissolved layer, and so we're going to have less rows in the attribute table, and somehow those values have to be combined.